My name is Christine Chai, and I am a software engineer at Microsoft, but my work is in statistics and data science. And in fact, I completed a PhD from Duke in statistical science. And today I'm really happy to talk about data visualization and accessibility today. So I believe most of you are familiar with data visualization, this term. So I'm going to get into what's accessibility. So accessibility is the practice of ensuring everyone can access our content, including people with disabilities. So in a user design course, I have heard that many people talk about how their applications are accessible 24/7 over the internet. That is called availability. That's not what we're talking about. We're talking about accessibility for people with disabilities, so that people with disabilities can enjoy equal access to our content. So thanks to assistive technology, now we can empower people with disabilities to access digital content. For example, computer magnifiers are available for people with low vision, and they can enlarge the words on a website to read them. And for another example, closed captioning from videos allows people who are deaf or hard of hearing to understand the video. And I'd like to emphasize that closed captioning actually benefits a lot more people than this group. For example, if the speaker says something and it is very difficult to understand, and the captions, the words will also help the audience to understand what the speaker is talking about. So accessibility has more benefits. And so what's the relationship between data visualization and accessibility? So the goal of data visualization is to convey the message from the data to the audience. It is the data presented in a visual way, in a graphical way, so people can understand the concepts or patterns. But some people can see the graph, but they cannot read it. And that's going to be a problem. And that's an accessibility issue because the graph is available to them, but it's not accessible. And so some of you may wonder, how can this happen? So let's look at this graph. This graph is about 3 people, Chris, Kelly, and Taylor. They tracked the number of books they read per year. And there are 3 lines indicating their records. And this graph looks readable on the surface. At least the X and Y axis labels are large enough. But some people are going to see the graph like this because they cannot see colors. We can see the gray line is for Chris, but we won't be able to tell which one is Kelly's and which one is Taylor. So, okay, I see the graph, but I cannot read it. It's not accessible. And this is a problem more common than we have imagined. So there are about 300 million people with color blindness in the world. And that's about 4.5% of the global population, or almost about the number of people living in the United States. So if we incorporate accessibility in data visualizations, these people can also be included in the potential audience. So this can increase our size of the potential audience pool. And a larger audience pool has better potential for more impact. So let's revisit the graph about the number of books read per year. So how do we improve accessibility? We can change the point shapes and line types. I created this graph in ggplot. So we can add code like scale color or scale line type, scale shape, especially the point shapes and the line types. Then we can change the graph to be like. So each trend can be identified in terms of color and also point shapes and line types. So why is this called accessible? Because if we look at a graph without color, we can still clearly identify each trend. So people who are unable to see colors can still read it, still understand this graph. And in R, there are many options for the point shapes, and we can mix and match and see which combinations work best. For example, it can be a good idea to use number 1 and number 17 because the shapes are different. But it would be a bad idea to use 17 and 24 because the only difference is the black and red colors. And for line types, R also provides multiple options, and my personal favorites are solid and dashed. We can also mix and match. So in accessible data visualizations, it not only benefits people with disabilities, but also benefits many other people. For instance, some people print the graph in black and white, so they won't be able to see color on a print version either. And if we use color responsibility, we can improve the readability of the graphs. And most importantly, it saves colors, saves costs in color printing. Like the Journal of the American Statistical Association, JASA, charges $400 for a color figure if the graph has to be printed in color. That's a lot of money. So what this means is that if we make the graph accessible, it does not need to be printed in color. Then we don't have to incur the extra cost. But if it is not accessible, it has to be printed in color, and we would have the extra charge. So making graphs accessible is good business practice. So the takeaways about color usage is that we can use color, and we can use that to our advantage, but we should not solely rely on color. So for each trend, they need to be distinguishable without the color. And we need to remember that accessibility benefits not only people with disabilities, but also improves the overall user experience. And for more accessible color usage ideas, there is a book written by Jerry Cody called Color Accessibility Workflow, and it introduces more guidelines. For example, like people with color blindness are still likely to distinguish between blue and yellow, but the majority of the people with color blindness have difficulty distinguishing red and green. But we have to be careful in using yellow when we have white background because they are both very light colors and it can be hard to read. For another example of data visualization, we are going to compare precipitation of two cities. And the two cities are Seattle and Phoenix. Seattle is the city where I live in. Well, I'm on the east side. I live in Redmond, actually, but it's close enough. And it has an oceanic climate famous for being cloudy and rainy often. And the summers are very cool. I remember enjoying a nice summer in Seattle last year. This year, I wish I could go out more often. But for Phoenix, it has a hot desert climate. So it is very hot, very dry, while summers are extremely hot and winters can be warm. However, sometimes in the summer, Phoenix can get thunderstorms that can produce heavy rain and dangerous winds. So that can produce a lot of precipitation, but it can also be considered a state emergency. So let's get into the graphs. I used data from Wikipedia, from their climate data. They have the monthly average precipitation from 1981 to 2010, and we can make a bar plot for Seattle and Phoenix. And I aligned the y-axis limit together. So this graph also looks fine, well, at least for now. But some people with low vision may not be able to see the precipitation bars of April, May, and June in Phoenix, for Phoenix. And they may have concerns about missing data. Is there any data over there? This can also happen when we print this graph on a poster and then people read the graph from a distance. They may not see the precipitation bars when they are too small. And so to resolve this issue, we need to add some labels to the tiny bars, tiny precipitation bars. So in ggplot2, we can create the labels and add them to the plot using the geom_text function. Well, seems like a lot of work, right? But it's doable. And then in a not so reproducible way, we can also do that in regular Paint apps, and then we just directly add the text to it. That also works. So anyway, the graph will become like this. So with the text on top, when people take a closer look using the magnifying app, we'll see, oh, there are actually data, even though the precipitation bars are still very small. The labels indicate its existence of the data. And to increase the audience pool to the global community, we need to include more people in our potential audience. Accessibility is to ensure that everyone can access our content, and everyone has different needs. International people may have different needs than the people in the United States, because many places on this planet use the metric system. They may be more familiar with millimeters than inches. They may use the Celsius temperature scale, while in the US we use the Fahrenheit temperature scale. And so accessibility includes people with disabilities, but that's not the only need. We are trying to include everyone. And for the metric system or the different units, we can add a secondary y-axis for the other unit. And in this way, people do not need to make the mental calculation in understanding the absolute value of the precipitation. And it looks like this. We can see on the left is precipitation in terms of inches, and on the right side is millimeters. And although I used colors in bars that distinguish between Seattle and Phoenix, this graph is still readable without color because the two subplots are labeled with the words. And if we want to compare the precipitation month by month, we can also do it this way. So directly see that the Seattle has much higher precipitation than Phoenix, except for in July and August, the Phoenix rains more because of the thunderstorms. And for the small precipitation bars, I made the text in the middle. And even without color, since the legend says Seattle is the left one, Phoenix is the right one, then we can still distinguish that other than the shades of the grayscale. And in summary, accessibility is to include everyone. And we need to remember that people access online content in many different ways. Some may need large print. Some may use different types of units. So the traditional advice, know the audience, still applies. And this also includes understanding their needs. And a larger audience pool means greater potential for impact. So the next question will be, what about the people with extremely low vision or totally blind? Then there are non-visual access of graphs. So I got this idea from the Grace Hopper celebration. Last year, I saw a presentation called Insight Without Sight. It was created by Ed Summers, the Director of Accessibility at SDSS. He's a blind software engineer with more than 20 years of experience in software development. And the team created the SDSS Graphic Accelerator. And this extension uses sound in addition to sight. So people who are blind or with extremely low vision can also access data visualizations. And I'm going to switch to a video clip from the SDSS Graphic Accelerator.
Sonification heading level 2.
And let's explore this graph using sound.
Tab, explore this histogram using sound link. Space. Horsepower. One region, one application, and no links. Chart off.
Within the sonification view, the SDSS Graphics Accelerator represents data on the y-axis using pitch. So data points that are low on the y-axis have a low pitch, and data points that are high on the y-axis have a high pitch. The x-axis is mapped to your left and right speakers. The data points on the left side of the x-axis are in your left speaker, and the data points on the right side of the x-axis are in your right speaker. Let's play this graph from left to right. Let's go back to the left side of the histogram and explore each data point interactively.
Horsepower equals 60% equals 0.2. Horsepower equals 100% equals 6.1. Horsepower equals 140% equals 15.2. Horsepower equals 180% equals 20.8. Horsepower equals 220% equals 26.9. Horsepower equals 260% equals 11.2. Horsepower equals 300% equals 11.7. Horsepower equals 340% equals 5.4. Horsepower equals 380% equals 0.9. Horsepower equals 420% equals 0.2. Horsepower equals 460% equals 0.5. Horsepower equals 500% equals 0.9.
The SDSS Graphics Accelerator is available now in the Chrome Web Store and the Mozilla Firefox Store.
I am not affiliated with SDSS, so I am not advertising for any software, but I'm showing that it is possible to use sound to access the data visualizations. And in the Insight Without Sight, they also translated a graph into Braille. So people can directly touch and then read the graph along with other Braille text. And if we want to make sure that our graph can be translated into Braille, we need to make sure that the message can be conveyed in the absence of color. And for Insight Without Sight, another example is a touchable geographic map. It is a 3-dimensional print. So it allows people to touch and feel the different geographic and different terrains on the map. And this would benefit people with low vision a lot because they can get the message from the fingers, from touching the geographic map. And as a person with sight, like I can see the map, but when I can also feel the different terrains, I'll be more excited to read and understand that geographic map. And this kind of map would draw a lot more attention than a flat one, a regular map. So making a map touchable, making it in 3-dimensional benefits everyone. For the people who cannot see well, they can understand it. And then for the people with sight, they can be excited about it. And this kind of map would draw a lot more attention, which is a very good thing. So in conclusion, accessibility means everyone should be able to read a graph, and this includes people with and without disabilities. And the principles I talked about today are technology agnosis, because these principles apply to most data visualization software, including RStudio, Python, and even Microsoft Excel. It is not that difficult to write code or modify the graph. The key point is the awareness of the accessibility issue. There are many quantified benefits of accessibility. For example, the World Economic Forum said that more than 3/4 of consumers are willing to buy something from a business which ensures access at their physical locations for people with disabilities, like ramps. And like creating ramps not only benefits for people using a wheelchair, but also for people who are carrying a heavy suitcase with wheels. And more than half of the consumers with disabilities would shop more often at stores that have made efforts to be accessible and welcome people with disabilities. And even a sign saying we welcome service animals would be helpful. And on the contrary, more than 70% of people with disabilities would leave a website when they find it difficult to use because of accessibility barriers. So making the physical location and the internet website accessible has a lot of benefits. They have the potential to generate more business revenue due to the increased willingness of people to purchase products. So as people working with data, we are accountable for the accessibility features of the data visualization. The creators of the graph are responsible to make the graph readable. And we need to remember that accessibility benefits not only people with disabilities, but also improves the overall user experience. So the final message would be data visualizations should be accessible. If not, we are not doing it right. And I'd like to thank a lot of my colleagues for the discussion, including the organizer of the accessibility training program, Manish Agrawal at Microsoft, and also the other Microsoft people like Toby Fitch and Stephanie Piccioccio. They contributed a lot on the discussions. And last but not least, Donna Lalonde from the Caucus for Women in Statistics at the mentoring program. I asked relevant questions and Donna volunteered to review the proposal before I submit it to this conference. And for more resources, there are many websites and online courses like Accessibility for Web Design that we can learn from. Thank you for listening.
Thank you, Christine, for a nice talk. So we have time for questions. So Stephanie, let me start by asking you, Christine, let me start by asking a question, which is sort of related to accessibility. So I think accessibility is a very nice idea, and all of us draw plots, and even though this should come naturally to all of us, at least I will confess that I have also missed this important piece in some of my plots that I've made in the past. So I think we all were taught about using triangles or symbols to represent plots or different sort of grouping variables. But I think the accessibility for the blind was, I think, a very, very important idea. So one of the videos that we showed, in which the x and y axes were represented through different pitches. The left hand side was mapped to a specific speaker and the right hand side to another one. So what if we wanted to convey more complicated graphs where we split through panels, something like a trellis plots? How do you have sort of explored these ideas further? Because I think these are very important for communicating, visualization in more complicated data, which I think in the modern perspective arrive more frequently.
So this is a very good question. Like the context of accessibility also extends to more complicated graphs. So for more complicated graphs, like choosing the colors, for example, if we have a scatter plot, in addition to colors, we can also change the point shapes so people will be able to read them without colors. And also, if the software provides like the default may not have enough font size, may have a smaller font size for the access labels, and we also need to enlarge them. And then if a graph is really, really complicated, then I wonder what is the intended audience. If the graph is really complicated, can the audience be able to understand the graph? And then if it's going to be a series of graphs, then I think it is also a good idea to create video as animation